Tonight we drift into the quiet, wondrous world of rivers, Earth's silent architects. These calm but determined waters carve paths through stone, nourish forests, and carry forgotten echoes of ancient lives in every grain of sand. A single river can sculpt an entire valley, breathe life into a city, or cradle the buried layers beneath towering mountains. Some flow unseen beneath the surface, some glimmer with rare minerals, and others follow routes once traced by vanished kingdoms or migrating herds. Each one holds its own mysteries, each one a storyteller shaped by time. Tonight, we'll explore the waterways that transformed continents, nurtured civilizations, and sculpted extraordinary wonders beneath their surfaces. From broad tropical channels to narrow desert streams, rivers reveal the slow, patient forces that shape our planet. If these gentle explorations bring you calm, feel free to like, subscribe, or share a thought below. It helps others find their way to this peaceful corner. For now, simply breathe. Let the weight of the day drift away as the quiet rhythm of water softens your thoughts. Let's begin. The hidden rivers, beneath the earth, underground rivers, move like the heartbeat of the planet. They travel through silent chambers where sunlight never enters, slipping into hair-thin cracks in limestone until the rock slowly opens like a hidden door. Over centuries, tiny trickles merge into powerful underground currents, carving out rooms big enough to swallow entire city blocks. Stalactites grow like frozen drops of time, and stone curtains ripple from the walls. In that deep quiet, the clock of geology ticks slowly. The land above may seem still, yet beneath it lies a maze of hollowed corridors. Where the ceilings remain strong, hills rise. Where they collapse, valleys form. Some forests stand on arches that once echoed with flowing water. And when a surface stream disappears into a sinkhole and re-emerges in another valley, it reveals the presence of these secret passageways. With patience beyond imagination, hidden rivers reshape the world from below. Civilizations shaped by water, the cities of the Indus Valley, once lived in harmony with the rhythm of their river. Long before written language captured daily life, settlements flourished along the floodplain, mastering the art of surviving a river that could be generous one year and unpredictable the next. Archaeologists have uncovered perfectly aligned streets designed to guide rising waters out of the city. Deep wells reach the clean groundwater renewed each year by melting snow from distant mountains. Farmers shaped the landscape by planting in the dark, fertile soil left behind after seasonal floods. Boats carried grain, pottery, and stone along water routes, binding towns into a thriving network. But as the climate shifted and the river lost its steady pulse, the cities slowly faded. What remains now carries the soft whisper of a civilization that once understood the power and rhythm of flowing water. Rivers that redraw coasts. Some rivers carry enough sediment to rewrite entire coastlines. As they travel from mountain springs to distant seas, they gather the material that once formed cliffs, forests, and plains, grain by grain. When their waters meet the ocean, the slowing currents release their burden, building vast deltas that stretch outward like giant fans. New land rises in shallow waves. Marshes form, winding channels weave new patterns across the map. Birds, fish, and small creatures claim these young landscapes long before people arrive. From above, these deltas resemble great fingerprints pressed into the shore. Over lifetimes and millennia, the patient work of a river can bend the edges of continents, nature's first calendars. Long before humans wrote the first symbols on clay, they learned to read the river's language. They noticed which stars appeared just before the floods, which insects emerged on muddy banks, and which winds swept through valleys on the eve of rising waters. These patterns became the earliest calendars. Stories told beside evening fires preserved the knowledge. Songs carried the wisdom of which days were safe for planting. Nature was the first teacher, and the river its quiet guide. Ceremonies were once held to announce the moment the waters would return, for everyone knew that the river's reborn flow would bring life back to the land. In some villages, symbols carved into stone pillars served as memory books, preserving the stories of great floods for future generations. Fields were planted atop the dark, nutrient-rich soil left behind by rising waters. Homes were built on elevated ground chosen long ago by those who understood the river's temperament. Even before writing existed, people learned to read their rivers, building cultures rooted in observation, patience, and respect for water. The Yukon River remains a silent witness to the journeys of people moving between continents. Through the long winters and brief, explosive summers of the north, the river winds through a wild landscape sculpted by ancient glaciers. Erosion reveals frozen layers of mud, natural time capsules holding what the centuries hid. Archaeologists have uncovered stone tools, animal bones, and small objects left by travelers who once crossed the land bridge connecting two worlds. These early wanderers used the river valley as a natural passage through harsh terrain, storing migrating fish for long periods and lighting fires even on treeless tundras using driftwood carried down from the highlands. As the glaciers retreated, the river buried these traces under fresh layers of sediment. Today, melting permafrost and collapsing banks expose relics untouched for thousands of years. Each discovery reveals a little more about how the first humans navigated vast lands, with rivers as their most reliable guides. Some rivers flow through several climate zones without ever losing their character. A single waterway may be born as snowmelt on a mountain peak, turn into a rushing torrent in pine forests, calm into a gentle stream in sunlit grasslands, and finally weave through humid, broad-leafed jungles. Though the scenery shifts, the river remains itself, gathering minerals from each landscape, blending mountain stone with valley soil and forest humus. Animals living along the same river may never meet, yet all depend on the same lifeline. For migrating fish, the river becomes a long thread, stitching distant climates together. For plants, seasonal floods deliver a rich mixture of sediments from many regions, creating new places for life to take root. Such rivers act like delicate weaving strands, connecting ecosystems that would otherwise remain isolated and forming an unbroken chain of life across great distances. Their continuous flow shapes the very structure of the lands they cross. Throughout history, shifts in a river's course have sparked conflicts. In some countries, political borders were drawn exactly along a river's path, yet water never stays still. Erosion deepens one bank while deposits build new land on the opposite side. A powerful flood can alter its direction overnight, dividing fields, gardens, even entire villages. When a river marks a boundary, every change invites dispute. One side claims the shifting waters have moved the border, the other insists the border is the river itself. Maps become obsolete, agreements uncertain, and territories can change hands in an instant. Some of these disputes have lasted decades because water refuses to hold a fixed line. Nutrient-bearing rivers feed not only their own banks, but the surrounding forests as well. Mountain rains loosen soil. Streams carry these particles and spread them across wide floodplains. When the waters recede, a thin, mineral-rich layer remains. Trees grip this renewed ground and grow stronger and denser. Floods bring seeds from distant regions, helping new plants take hold. Migrating fish return carrying ocean-borne nutrients. After spawning, their bodies enrich the river system. Animals feeding at the water's edge carry these nutrients into the forest. In this way, a river's influence reaches far beyond its channel. The Peruna River was once powerful enough to create new islands across the vast floodplains of South America, carrying immense loads of sand, clay, and organic material from high mountain valleys. The river spread wide during rainy seasons, dropping its burden as the current weakened. Over time, the accumulating sediments rose above the surface. First reeds and grasses anchored the soft ground, then shrubs and young trees took root. Birds, insects, and small animals filled this emerging habitat. Channels shifted around the rising landmass, forming a braided network of water that wrapped itself like a woven pattern around the newborn island. Some islands grow stable enough to support forests, while others drift slowly as the river reshapes them grain by grain. What appears to be solid land is often the living handiwork of a powerful river building its own geography. River sediments carry traces of ancient atmospheres. As raindrops fall, they absorb gases from the air, imprinting a chemical snapshot of the sky at that moment. When those drops strike soil and stone, they lift microscopic particles that hold clues about vegetation, weather patterns, and even far-off volcanic eruptions. Streams gather this mixture and deliver it to wider channels where it settles as layers of fine mud and sand. Over centuries, these layers stack like pages in a vast archive. Scientists extract cores from old floodplains and read the past within them. Shifts in the ratios of certain elements reveal changes in temperature, rainfall, and vegetation. Tiny shells made by microorganisms record variations in water chemistry, and even the shapes of trapped pollen grains show which plants thrived or declined. Through these minute fragments, a river preserves stories of skies long gone and offers a way to reconstruct climates long before humans measured them. The Amazon sends a river of vapor across the continent. Moisture rising from the dense canopy forms a towering invisible highway in the atmosphere. Every tree releases droplets from its leaves, and together millions of trees create a moving pillar of humidity that flows like a steady current in the sky. Winds push this moisture westward, carrying it into dry interior regions that depend on it for rain. Meteorologists have followed these drifting corridors of vapor and found that their influence reaches even the distant mountains where the air cools and releases its load as rain or snow. Farmers, forests, and entire ecosystems rely on this airborne stream to survive seasonal droughts. When storms form far away, their strength and timing often reflect the quiet presence of this wandering moisture. Acting as a bridge between climates, it links humid lowlands with high plateaus, an endless cycle sustained by the silent breath of countless leaves. Some river mouths create underwater fans larger than entire nations. When strong currents reach the open sea, They slow and drop the immense volumes of sediment carried from deep within the continent. Clouds of sand, silt, and clay drift downward and settle on the seabed. Over time, they spread outward, forming vast submarine fans that can stretch across great distances. These submerged landscapes are sculpted by hidden currents that carve branching channels reminiscent of the patterns seen in deltas above water. Marine life flourishes on these new surfaces, feeding on nutrients washed from the land. As the structures grow, they can alter ocean circulation, influence fish migration routes, and even shift local climates. In some regions, underwater canyons slice through these deposits, guiding deep, nutrient-rich currents upward toward the surface. What appears flat from above often hides a complex and dynamic world, shaped by sediments carried from rivers hundreds of kilometers away. Meanwhile, the soil of a floodplain carries its own record of humanity. Each time the river spilled over its banks in ancient times, it left a thin layer of fertile earth behind. Within these layers lie fragments of pottery, stone flakes, seeds, pollen, and faint traces of early hearths. Archaeologists cut through these deposits and reveal scenes from lives long vanished. Some layers hold the remnants of early farmers who cultivated wheat and barley along narrow bands of moisture, while others preserve the bones of wild animals that roamed the valley before cities existed. Even the chemistry of the soil records shifting conditions. Some bands mark years of violent flooding, while others reflect droughts that strain harvests. Every layer forms a quiet chapter in the long story of societies that depended on predictable cycles for survival. By reading the earth beneath their feet, researchers uncover the origins of beliefs, rituals, and technologies shaped by rivers that provided food, transport, and stability for countless generations. And in some places, rivers emerge from caves that remain in darkness for miles, flowing through silent chambers untouched by sunlight. There are places where a shallow surface current slips into a narrow fissure and suddenly enters a realm of absolute darkness. The passage widens into towering chambers where rushing water echoes through rooms that have never seen daylight. Minerals dissolved in the flow stain the stone with curtains, spirals, and glossy sheets, patterns carved by centuries of steady dripping. Blind fish move through these shadowed corridors, guided only by touch and vibration. Crickets and tiny insects wander the damp walls in search of food, living entire lives without ever encountering the sun. These caverns expand as water grinds the bedrock grain by grain, and in some places, ceilings collapse to create hidden waterfalls that tumble into silent underground pools. Explorers who descend into these passageways often discover stacks of geological layers, pressed together or separated by narrow seams, each layer formed during a different era of rain and climate. Within these labyrinths, we're reminded that rivers shape not only the bright world above, but also unseen realms below, each inhabited by its own quiet communities. The Congo River holds currents strong enough to divide species over time. In Central Africa, a chain of fierce rapids forms a natural barrier, unlike anything else on the continent. Fish swimming upstream encounter swirling vortices, sudden drops, and compressed channels where the water surges with enormous force. Over long stretches of history, these obstacles isolated populations into separated pockets. Without contact, each group adapted to its own environment. Some evolve in body shapes that cling to rocks, others refining sensors that detect the trembling pulse of turbulent water. Genetic studies reveal patterns of divergence that match the structure of the rapids themselves. The river's movement restricts travel and dictates the conditions each organism must survive, turning narrow, fast-flowing reaches into engines of evolutionary change. Some rivers are older than the mountains they now pass through. Long before dramatic peaks lifted into the sky, certain waterways flowed across broad plains that stretched to distant horizons. As tectonic forces pushed the land upward, these persistent rivers cut downward with equal determination. Unwilling to change course, they carved deep canyons through the rising ridges, slicing straight across mountain chains. The resulting gorges expose rock layers far more ancient than the rivers that shaped them. Yet the channels survived because their flow remained strong enough to outpace the uplift. Travelers who stand within these chasms witness the outcome of a timeless contest between land and water. Sheer cliffs rising on both sides, while the river continues its quiet course, as it has for millions of years. Geologists read these pathways to reconstruct the birth and growth of mountain ranges. The landscapes show that even towering summits cannot always force a river to bend. For thousands of years, the Danube has served as a cultural artery. Communities along its long European route have exchanged ideas, goods, and stories since deep prehistory. Boats carried pottery, amber, metals, and grain between distant regions long before roads united them. Settlements grew along its banks because the river offered food, transport, and fertile soil. Empires relied on it as both a boundary and a lifeline, sending messages and armies along its steady course. Monasteries, fortresses, and trading towns rose wherever the landscape offered safe harbors. Languages blended, beliefs crossed borders, and culinary traditions merged as travelers followed the current. Even today, the river anchors the identity of the nations it threads through. Flowing water reveals how separate peoples can become part of a single connected corridor, carrying knowledge and influence through places that would otherwise remain strangers. In cold regions, winter ice slowly sculpts valleys. Layer by layer, water freezes and turns the channel into a solid mass that presses outward against the banks. As temperatures shift, cracks form and fill with meltwater, which expands again as it refreezes. This cycle pries rocks apart and weakens the surrounding soil. When spring floods arrive, the loosened material breaks free and joins the flow. Over countless winters, this quiet process widens valleys and deepens channels without the dramatic violence of a storm. In some areas, massive sheets of ice drift downstream, like moving stone grinding into the riverbed. They drag boulders, carve grooves, and shatter smaller rocks. Researchers study these patterns, striated surfaces and scattered debris, to trace the paths left behind. Though ice appears still, its repeated advance and retreat reshapes entire landscapes in ways too slow for a single lifetime to notice. The Meong River, meanwhile, sends out an annual wave of floodwater that sustains millions of people and nourishes the land on which they depend. Each year, rains rising from distant mountain ranges swell this river until the valley expands into a vast inland sea. As the water climbs, fish move into the flooded forests, feeding on fallen fruit, drifting leaves and insects sheltering among the branches. The people who live here shape their routines around this rhythm. Farmers, fishers, and gatherers all adjust their work to the pulse of the water, When the flood retreats, the land transforms again, revealing broad basins coated in rich dark sediment that nourish the rice fields. Villages, built high on wooden stilts, allow families to live safely above the shifting currents. The receding water leaves behind fertile soil that can sustain entire communities. Markets overflow with fish during the peak season, and the floodplain becomes a bustling center of life. This annual rise and fall binds human lives and ecosystems into a single shared cycle. Elsewhere in the world, some rivers run so clear that sunlight reaches the bottom without interruption. In rare landscapes where erosion is minimal and loose sediment is scarce, water flows over stone and sand without gathering murk. Every pebble and ridge appears sharply defined beneath the surface. Fish drift in current as if suspended in air, while rooted plants sway in slow underwater arcs. Sunbeams travel almost untouched through the channel, illuminating rocks and hidden crevices. This clarity creates cool, oxygen-rich conditions that support delicate species unable to live in clouded waters. Visitors standing on bridges or riverbanks can watch the entire underwater realm unfold beneath them, from tiny insects clinging to stones to the shadows of larger creatures gliding through deeper pools. Such rivers reveal the quiet beauty of water in its purest form. Far-off deserts owe their towering dunes to journeys that begin in rivers like these. Grains of sand break from mountain stone, carried into swift channels, where they are ground smaller and smaller. When the floods ease and the flow slows, the particles settle along the riverbanks, waiting for the next stage of their travels. Eventually, the wind sweeps the lightest grains into open deserts, bouncing them forward in tiny leaps until they gather into dunes. Some move only a few meters each year, while others shift across the landscape with surprising speed. Plants and animals adapt to these migrating forms, finding shelter in the hollows and ridges. From above, satellite images reveal long trails of dunes tracing the invisible paths of the winds. What begins as river sediment becomes a moving architecture shaped entirely by air. The river itself has never stayed fixed. For centuries, settlements have relied on its steady flow for trade, travel, and fertile land. Yet the waterway continually redraws its path. Natural shifts have changed shorelines, flooded fields, and created new islands. As towns expanded, attempts to control the river grew more ambitious. Marshes were drained, artificial channels were carved, and levees were built to force the water into straighter lines. Old meanders became quiet oxbow lakes, and abandoned channels turned to meadows. Maps from different eras show the river's shape changing dramatically over time. These transformations reshaped fishing grounds, travel routes, and local economies. Even now, the river responds to climate patterns, rainfall, and the slow buildup of sediment. The landscape along its banks is a record of centuries of cooperation and conflict between flowing water and human hands. During powerful storms, even trees can become extraordinary travelers. Fierce currents tear dead trunks from the riverbanks, but some are carried away still standing upright, anchored by clumps of soil tangled in their roots. These floating pillars glide with the flow, their branches stretching toward the sky as if walking on the water. They can travel great distances without tipping, creating temporary shelters for fish, turtles, and insects that gather around their drifting shadows. In moments like these, nature reveals its constant motion in the most unexpected ways. Birds often perch on drifting logs, using them as brief resting spots between flights. When those trees eventually strike rocks or settle in shallow areas, they alter the flow and create new habitats that can last for years. What begins as the violent aftermath of a flood becomes an unexpected moment of elegance as entire trunks travel upright, moving like living sculptures along the current. The Mississippi River has built an entire region through its constant delivery of sediment. As it crosses the continent, it gathers minerals and organic fragments from thousands of tributaries. During each flood season, the river spreads across the land, carrying its load toward the sea. Near the coast, the slowing current drops this material in thick layers that slowly rise above the water. Over centuries, these deposits have formed plains capable of supporting forests, farms, towns, and wetlands. Channels wander through this ever-growing expanse, abandoning old paths and carving new ones. Areas that now seem like firm ground were once shallow lake beds. Vegetation stabilizes the accumulating soil, allowing the next generation of sediment to rise even higher. With time, the expanding delta branches outward like the limbs of a vast tree. The scale is astonishing, an entire landscape built from the quiet labor of water, transporting the remnants of far-off mountains. In the Amazon, rivers heated almost to boiling lie, hidden within the rainforest. Even on cool mornings, steam curls from their surfaces. These unusual waters are not warmed by magma, but by underground springs that feed the channels with intensely hot water. As the river flows, its temperature remains dangerously high, creating a habitat where few animals can survive. Falling leaves soften instantly, and small creatures that slip into the current perish quickly. Yet along the cooler edges, specialized plants and microorganisms thrive. The heat originates deep underground, where groundwater passes through layers of rock warmed long before it surfaces. Local communities have known these rivers for generations, treating them with a blend of caution and respect. Scientists studying them gain rare insight into the interactions between geothermal heat, groundwater, and rainforest hydrology. In some of the world's most remote regions, step terraces rise along riverbanks, recording long histories of climate change. Each level marks an ancient floodplain carved when the river once flowed at a different height. Over thousands of years, shifts in climate altered rainfall and reshaped the river's strength. During wet periods, the river cut deeper, leaving older terraces perched high above the new channel. During drier times, slower flows spread across wide surfaces, depositing fresh layers of silt. These stacked platforms preserve traces of past vegetation, temperatures, and rainfall. Fossils, pollen, and buried soils inside the terraces reveal detailed snapshots of the ecosystems that once existed there. By reading these layered shelves, researchers can reconstruct long-term environmental patterns and understand how rivers respond to shifting climates. Each terrace stands as a quiet record of a world that once occupied that height. The Tigris and Euphrates supported irrigation systems far beyond the needs of their own eras. Along the floodplains of ancient Mesopotamia, early societies built channels that guided water from the main rivers into distant fields. Mud and clay embankments were shaped carefully to control how much water each plot received. Gatekeepers used simple wooden and stone mechanisms to regulate the flow. Entire cities depended on this network, and its success allowed markets, temples, and administrative systems to flourish. Even as riverbeds shifted, the old canal outlines remained etched into the land, forming patterns still visible from satellites today. Their engineering reveals how deeply these early cultures understood their environment. Without detailed knowledge of seasonal shifts and soil behavior, the region could never have supported the vast populations that once lived between the two rivers. Mineral-rich rivers build rising terraces of travertine year after year. Flowing through limestone regions, water dissolves suspended minerals until it spills over a ledge or cascades down a cliff. As the water arcs through the air, carbon dioxide escapes and thin layers of calcite are left behind. Over time, these delicate sheets grow into terraces, ridges, and striking steps of pale stone, creating landscapes sculpted by nothing more than water, minerals, and time. The river carries the memory of ancient glacial lakes that once blanketed Siberia. During the last ice ages, towering walls of ice dammed entire valleys, trapping meltwater in vast basins. When the climate warmed and the glaciers retreated, those lakes burst in catastrophic floods, carving deep scars into the land. Along this long northern river, scientists still find traces of those events preserved in gravel bars, terraces, and buried sediments. The scattered stones reveal where powerful currents once roared and carried material from now elevated landscapes. Thin layers of silt record the quiet centuries when enormous lakes stood still, reflecting pale skies before slowly vanishing. Fossil pollen hidden in the sediments shows which plants endured the cold and which arrived only after the world softened again. By studying these layers, researchers rebuild transformations that shaped Siberia long before written history existed. The river becomes a natural archive of sliding ice, vanished shorelines, and the immense forces that once ruled the north. Its floodplains store carbon in layers that outlive civilizations. Each time rising water spreads across the land, a film of mud and organic matter settles over the soil. Fallen leaves, broken reeds, and microscopic plant fibers sink into the wet ground. Season after season, these materials accumulate into deep horizons that trap carbon drawn from the air by earlier forests. Beneath the surface, where oxygen fades, decay slows dramatically. New layers seal the old ones, locking away carbon that might otherwise return to the atmosphere. Over centuries, this slow burial creates rich dark soils, quiet reservoirs that help balance the exchange of gases between land and sky. Archaeologists often find traces of early farming communities preserved in these layers, yet the carbon beneath them may have formed long before humans arrived. Far away, the Colorado River has carved canyons that reveal nearly half the planet's geological history. In the American Southwest, it winds between stone walls stacked like pages of an immense archive. Each band marks a time when seas advanced or withdrew, when deserts formed and disappeared, when mountains rose and wore away. Patiently, the river cut deeper, exposing colors from pale cream to dark rust. Some layers hold fossils of marine creatures, reminders of warm, shallow waters that once covered the region. Elsewhere, wind-shaped ripples remain frozen in stone. Geologists read these layers like a timeline stretching back billions of years as the channel continues etching new details each season. Yet rivers can also mirror the night sky with flawless clarity. On still, windless nights, when currents soften and the surface turns to dark glass, stars shimmer with unexpected precision. Tree-lined banks fade to silhouettes as constellations gleam on the water. The sky seems doubled, blurring the boundary between earth and above. Fireflies drifting along the shore look like sparks wandering between two worlds. Animals stepping to the water's edge appear suspended in the mirrored universe. Even faint stars, often swallowed by city light, emerge in this quiet phenomenon, turning the river into a natural observatory. Elsewhere, the Orinoco links entire basins through a seasonal channel. During the rainy months of northern South America, rising water opens a temporary passage between two great river systems. Fish that normally live in separate regions travel through this short-lived corridor, exploring new feeding grounds and expanding their ranges. Birds follow the spreading wetlands, and plants adapted to fluctuating waters thrive. When the flood recedes, the passage closes, yet species that successfully crossed may remain, enriching ecosystems. Scientists study this brief annual event to understand how water can bind vast landscapes into a single breathing system. Some rivers build their own levees as they rise. During floods, heavy sediments settle nearest the banks, forming low ridges that grow with each season. These natural embankments guide the river's future path, while finer particles drift farther away, creating fertile soils for forests and agriculture. Raised margins influence where the next flood will spill, carving new routes or reshaping the channel entirely. Structures formed not by human hands but by the constant labor of moving water. The Zambezi River creates rainbows that linger for hours. Near its famous waterfall, immense sheets of water plunge into a canyon and explode into mist. Sunlight catches the drifting droplets, producing wide arcs of color that can glow through entire mornings. On especially humid days, overlapping bows shimmer as the angle of the sun changes. Even after the roar of the falls fades in the distance, the light show continues. At night, moonlight can summon faint, silvery rainbows, rarer and almost dreamlike. The combination of deep valleys, powerful water, and perfect air makes this one of the few places where such scenes endure so long. And in the oceans, underwater waterfalls form where heavier, salt-rich currents slip beneath lighter flows. As the dense water plunges downward, it creates hidden cascades, massive, silent drops that reshape the movement of nutrients and marine life. These submerged falls can stretch for astonishing distances, sculpting the invisible pathways of the deep. Beneath warmer layers, cold and dense currents slide like invisible rivers, carrying oxygen into deep regions that would otherwise remain breathless. As these layers mix, swirling patterns unfold, creating underwater vortices that twist through the dark. Scientists track these hidden motions using instruments that register shifts in temperature and salinity as they descend. The flows carve subtle pathways across the seafloor, building ridges and troughs much like surface rivers sculpt their valleys. In this shadowed world where gravity and density dictate direction, unseen waterways move with quiet determination, revealing the ocean's inner architecture. Long before stone observatories or star charts existed, early sky watchers learned to read the heavens through the behavior of rivers. Changes in water level echoed the appearance of familiar constellations, or the rising of certain stars. Floods, drought-like lows, and even tiny shifts in clarity signaled the turning of the year. Communities placed markers along the banks to compare heights, from one season to the next, and these became some of the earliest tools for measuring time. Priests and observers linked repeating water patterns to lunar cycles and the lengthening or shortening of days. In some regions, still night waters mirrored the sky so clearly that people traced the movements of planets by looking down, not up. The steady rhythm of a river offered a reliable reference point against the shifting heavens, guiding agricultural calendars, festival dates, and early navigation for generations. The river's gentle rise and fall became the first tutor in understanding how the sky itself changed. Far north, the Lena River has sculpted pillars of ice-sculpted stone that rise like natural cathedrals. In this deep winterland, towering cliffs stand above the water, carved by frost, wind, and the persistent push of the current. The formations appear as long rows of slender stone towers, separated by narrow corridors and arches found nowhere else on Earth. During warmer days, melting ice seeps into cracks and freezes again at night, slowly prying the rock apart. Over ages, entire columns merge from eroded ridges. Snow collects in their shadows, and migrating birds rest on the ledges overlooking a frozen world. The river continues shaping their bases, cutting reflective channels that hold the faint light of short northern days. When fog drifts across the water, the pillars rise like spectral spires, offering a glimpse into the long partnership between ice, stone, and flowing water. Some rivers carry magnetic glues that record the shifting of Earth's poles. As water upstream grinds against rocks, it gathers tiny mineral grains whose magnetic particles align with the direction of the planet's field at the moment they form. These particles drift downstream and settle into layers of mud and sand. Once buried, their original orientation locks into place. By sampling old riverbeds and floodplain deposits, scientists can measure these faint signatures. Some layers point in directions that differ drastically from the modern field, revealing times when Earth's magnetism weakened or reversed. These traces help reconstruct the timeline of geomagnetic flips and the long-term behavior of the planet's core. They also show how river systems responded to global changes, preserving clues about ancient climates and environments. In this way, quiet sediment becomes a record of restless forces deep beneath Earth's surface. The Salween River flows through landscapes untouched by massive engineering. In remote parts of Southeast Asia, it winds between rugged mountains and wild valleys that have remained largely unchanged. Steep cliffs rise above narrow passages where the river rushes through untouched forests. Villages along the banks are small, built from local materials, and leave only gentle marks on the land. With no major dams or diversions, the river follows its natural rhythm, swelling during monsoon rains and shrinking in the dry months. Fish that rely on uninterrupted flow still migrate through its channels. Floodplains breathe with the ancient rhythm of rising and falling water. Monsoon clouds gather on mountain slopes, sending fresh surges into the tributaries that join the main flow. Because so much of the basin remains unaltered by modern infrastructure, scientists regard it as a rare example of a large river system, functioning much as it did before widespread human development. At its mouth, the blend of fresh and salt water forms nurseries for species that will eventually populate vast stretches of ocean. Here, mixing waters create an environment rich with life, shaped by forces that remain mostly wild. Shallow channels, mudflats, and tidal marshes act as nurseries for young fish that would struggle to survive in the harsher waters offshore. Nutrients carried downstream blend with minerals stirred up by the tides, creating a fertile mixture that fuels rapid growth. Crabs wander across the soft sediment, feeding on the microscopic life flourishing within this rich stew. Birds gather in great numbers to hunt in the tidal pools. Many species use these transitional waters only at the beginning of their lives, gaining strength before venturing into the open sea. Years later, some return to the very sheltered inlets where they once fed as juveniles, using them as breeding grounds. These protected spaces support global food webs. By allowing young marine creatures to grow safely, without them, countless ocean populations would decline. The ancient Nepa River once linked forest kingdoms to the powerful realms in the south. In earlier ages, it wound through regions home to communities that differed in language, custom, and way of life. Traders followed the current from northern woodlands toward southern plains, carrying furs, honey, metalwork, and handmade tools. Dugout canoes drifted past settlements perched on high cliffs, stopping at marketplaces where goods changed hands. As navigation improved, larger vessels carried merchant caravans through far-off lands. The river became a vital passage, connecting forest dwellers to the dominant states near the Black Sea. Fortified towns rose along its banks to safeguard this valuable trade. Early travelers wrote of encounters between diverse peoples who gathered at river crossings to forge alliances and negotiate agreements. Over time, the waterway shaped political borders and cultural identities. Its role in binding distant societies shows how a single flowing corridor can weave entire regions into a shared economic and cultural network. Some fish navigate entire river systems guided only by scent. Certain species possess an extraordinary ability to detect faint chemical traces in the water. As juveniles, they absorb the signature odor of their birthplace, imprinting it so deeply that they can recognize it years later. When the time comes to return, they follow these delicate signals across vast distances. As they near familiar tributaries, they sense subtle differences in the water column. Each branching path carries a unique blend of minerals and organic compounds, allowing the fish to choose the correct direction. Tiny variations in temperature or flow are also detected by specialized organs. This remarkable navigation system guides them back to spawning grounds hidden in remote valleys or high mountain streams. Researchers studying this behavior have found that the imprint remains astonishingly precise. Fish distinguish neighboring tributaries by differences so subtle that instruments struggle to measure them. Their journey reveals a sensory world shaped by chemical messages that most creatures can never perceive. The Murray-Darling Basin hides ancient riverbeds beneath its modern waterways. Deep in Australia's interior, sediments from long-vanished rivers rest beneath younger channels. These buried paths once carried water across landscapes transformed by shifting climates and retreating inland seas. Over thousands of years, their beds filled with sand, clay, and silt, and new rivers formed above them. Using tools that probe the soil, scientists have traced these forgotten roots beneath fields, plains, and present-day floodplains. Some of the old channels contain mineral deposits that reveal how past climates influenced erosion and rainfall. Preserved roots, pollen, and shells trapped within the sediments show which plants and animals once lived along their shores. Today's rivers still shape the region, but the unseen network beneath them tells a deeper story, one of landscapes evolving through cycles of drought and renewal, of waterways shifting to follow new slopes, while keeping traces of their former paths. Ancient roots embedded in the soil mark the memory of lost ecosystems, tiny air bubbles trapped in river ice hole clues to long-forgotten atmospheres. When winter freezes a river into clear layers, pockets of air become sealed inside. Each bubble preserves the chemical imprint of the atmosphere at the moment it was captured. As snow accumulates, lower layers compress into solid masses that protect the bubbles for years. Scientists extract pieces of old ice and measure the gases within. Ratios of oxygen and carbon dioxide reveal temperature, vegetation, and environmental conditions at the time the ice formed. Thin streaks of volcanic ash sometimes appear, marking distant eruptions that scattered particles across the world. Studying these frozen samples uncovers regional climate patterns and shows how river valleys responded to extreme cold or warmth. Each bubble is a tiny archive of the air that once drifted above the water before winter locked it in transparent crystal. The Fraser River supports salmon migrations on a scale rarely seen elsewhere. Flowing along Canada's western edge, it provides a route that stretches for hundreds of kilometers. Each year, salmon return from the ocean and swim upstream toward the streams where they first emerged from gravel beds. Their journey demands immense strength, bounding over obstacles, forcing their way through rapids, navigating shifting depths. Their arrival transforms the ecosystem. Eagles gather along the banks to feed. Bears wade into narrow channels to catch the passing fish. When salmon decay, the nutrients released enrich the soil, feeding the forests that stand along the river. In this way, a single migration nourishes an entire landscape. After fish complete their life cycle and release nutrients back into the water, the communities along the riverbanks, who have relied on this seasonal rhythm for centuries, shape their traditions, ceremonies, and stories around the Great Migration. The sheer number of fish moving through the current creates waves of color and motion, revealing how a single river's steady pulse can sustain an entire web of life. Some rivers don't simply flow downward, they drift sideways across wide floodplains where the land barely slopes toward the sea. Here, the water becomes patient yet mischievous, gnawing at outer banks, loosening roots, and carving through soil. On the inside of each bend, the current softens, allowing fine grains of sand and silt to settle and form new patches of land. Over time, a curve can reverse direction as its outer edge retreats and the inner edge expands. Abandoned bends turn into small lakes, and young meanders grow into fertile ribbons of soil. Villages once distant from the water suddenly find the channel creeping closer with every passing season. Entire valleys become gentle tapestries, shaped by a river that prefers to wander rather than rush straight to the ocean. The Seine River has also been reshaped for centuries to meet the needs of expanding cities. Early settlements relied on natural banks, shallow crossings, and soft islands, using them as safe harbors and market sites. As towns grew, new channels were cut to control seasonal floods, and stone embankments were built to ease navigation. Over generations, meanders were straightened, side channels redirected, and ferries replaced by bridges that subtly altered the flow. Later, the riverbed was deepened to support trade ships carrying grain, wine, textiles, and countless goods. Modern boulevards, promenades, and ports eventually transformed the entire shoreline. Yet beneath the polished surface of today's riverfront lie the memories of every shape the water once held. Rain, tides, and the quiet weight of sediment still influence the city's rhythm, continuing an endless conversation between the river and the place it divides. Riverbanks also supplied pigments for some of the earliest human art. Long before minerals were mined or synthetic dyes existed, early artists gathered natural colors from the silty layers left behind after floods. These soft deposits, rich in clay and iron, crumbled easily and could be ground into powder. Mixed with water, plant oils, or animal fat, they adhered to stone walls and carved surfaces as vivid paints. Some layers yielded warm reds and browns, others pale yellows or muted grays. Knowing which bank held which color, people returned year after year to collect this natural palette. The paintings created with these pigments have survived for millennia in caves and rock shelters, preserving animals, rituals, and imagined worlds in hues once carried by the river itself. A few rivers offer yet another wonder. Under certain light, their waters glow. Dissolved organic matter from forests, wetlands, and decaying plants alters the way light scatters through the current. When the moon is bright or the sun sits low on the horizon, the water takes on a soft inner radiance. This gentle shimmer reminds us that a river is not merely a moving channel, but a living presence intertwined with light, soil, and the shifting rhythms of its landscape. The surface sometimes shimmers with copper, gold, or greenish reflections as the currents glide beneath it. When plankton and other tiny organisms drift through nutrient-rich layers, faint pulses of light ripple through the water, as if the river were breathing from within. In the still pockets, untouched by wind or waves, this luminous dance becomes most visible. Scientists study these glowing waters to understand how nutrients travel from land into rivers and how seasonal changes shape entire ecosystems. At night, this gentle radiance rising from the water has become almost a cultural marker for nearby communities, creating the image of a river that carries its own soft glow through the darkness. The Tyrium River, with its unusual nature, even contributed to the preservation of desert mummies. In one of the driest regions on Earth, a narrow ribbon of meltwater from distant mountains once flowed through salt flats and dunes, sustaining life. Ancient peoples shaped both agriculture and herding around this fragile thread of water. When people were buried, the arid climate, mineral-rich soil, and the faint touch of groundwater slowed decay almost to a standstill. Textiles, wooden tools, even hair and facial features remained remarkably intact for thousands of years. Over time, the river shifted its path, leaving some graves outside the reach of water, later burying them beneath deep, wind-blown sand. Within these rediscovered burials, researchers found garments whose weaving was still visible, delicate tools of daily life, and traces of the journeys these communities once took. Their preservation was not an intentional design, but the quiet harmony of river moisture, harsh climate, and unique soil chemistry. Flood cycles in some rivers follow the breathing of distant oceans rather than local rains. In tropical and subtropical regions, waterways rise and fall with atmospheric patterns that sweep across continents. Warming oceans redirect winds, influence where storms gather, and determine how much rain a river basin receives. Even inland rivers respond to these faraway interactions. Some years they rise with powerful floods, other years they retreat into calm, narrow channels. Layers of sediment record these rhythms, alternating fine and coarse material that marks wetter and drier periods. Communities living along these banks learn to read this distant pulse, shaping traditional knowledge around it. Modern research confirms how strong these connections truly are. The movements of oceans thousands of kilometers away guide the heartbeat of rivers deep within continental valleys.